Hi all and welcome to the demonstration video for the summer internship SpyEye, real-time face detection using the Meta API. So without any further ado, I'll first explain how the project works and then deep down into the code in the top-down fashion. So here we are running the main Python script for the project, which will load up our web camera. As you can see on the screen, the main camera has been loaded and it is accurately detecting our face 1. At the top left corner is the number of faces identified in the image and in the video stream, and the blue highlighted border shows the face where it is present in the frame. The white line that you can see 200 pixels from the top is the intrusion detection line, and whenever any face crosses that line, that particular face snapshot is taken and then a 2-second buffer is created to prevent jittery images from being captured within like millisecond time gaps. So 2-second time gap is preferred. Now I'll end the video stream and you can see the images side by side. So the black and white images are the canny edge detection images, which are helpful to see the edges present of the face of the person, and even the original images can be seen. These pop up live as and when the face is detected, but there are other methods to view this as well, which I'll show now. So finally in the prompt we are asked if we wanted to see the saved images, that is the original image and the canny image side by side. I'll click yes. So totally 3 snapshots were taken. This is the first snapshot where the pair is the original image and the canny edge detection image. Secondly is the second pair of image, the original image and the canny edge detection. Notice at the bottom left corner there's also the timestamp, the date and time when the image was captured, and similarly the third and the last pair. Along with the pop-up of the images in real time, they're also saved in the folder over here under the saved folder. Under that the subfolders original and canny. Along with this, we have also included alert systems via WhatsApp, the Meta API, and using the SMTP port for sending a mail to the client, the stakeholder, which will be explained in the subsequent part of this demonstration video. So coming to the code, initially we initialize the webcam for having 1280 pixels width and 720 pixels height. In this continuous running while loop, we first read the frame from the video stream, and then we copy the frame later. We make a copy of the frame to save the frame without the white line and the warning text, which I'll explain in the save image function. Before this, let me explain the global variables that are present. Line Y is that white intruder detection line that you saw at the start, which is 200 pixels from the top. Currently the boolean variables WhatsApp and mail are set to false, but they'll be set to true and their functionality will be demonstrated in the later part of this video. Before each run of the main while loop, we delete the images stored in the original and canny folders so that there is no redundancy and excessive storage space wastage. The last 2 global variables are the time interval between any 2 snapshots captured, which currently is 2 seconds, and the last save time just saves when was the last time a snapshot was saved, which is used for the time interval saving calculation. Now coming back to the main while loop. So after we read a frame, initially we draw a line at the top of the frame. After we read the frame, we convert that frame to grayscale and then use the har cascade frontal face classifier, which is an XML file, to detect the faces in that grayscale image. After the faces are detected in that grayscale image, we draw rectangles based on the coordinates of x, y, width and height of the face. After we draw the rectangles for the faces and point out the number of faces present in the image in the top left corner, we check if any face is crossing the intrusion detection line, any faces coming above that line, and if it is, we save the image, we show it as a pop-up, we send an email and WhatsApp via multi-threading. And lastly, if the user wants to exit this while loop, he can either press the escape or Q key on his keyboard. And finally, a prompt is given to the user as to whether he wants to see the original and canny images pairs side by side. Now I'll explain each of the functions in a bit of an overview style. So this is the draw rectangles function, which basically takes the two arguments, the input frame and the faces that were detected in the frame. So firstly what it does is, using this if condition, it checks if that face detection was actually accurate. Har cascade actually is already accurate, but this is an additional level of security check that we're doing in case it misclassified any small object also as a face. So the criteria is that the face should be at least 50 pixels in width and at least 50 pixels in height. And if it is, we draw the blue color rectangle around that frame, around that face, and we put the text denoting which serial number it is, like face 1, face 2 that you saw before. After that, at the top left corner, we also highlighted the number of faces present in the current frame, which is shown here. Next up, in the checked line crossing function, we accept three arguments, which is the faces array, the frame and the frame copy. So here what we do is we iterate through the faces array, which is a 4-tuple consisting of the coordinates of the top left corner, the width and the height, which is sufficient information to get the coordinates of the rectangle. Now if the user's face was above the intrusion detection line, we put this following text in red color warning the face cross line, and then the frame copy that we had initially mentioned without the white intrusion detection line and without this warning text, that particular frame copy is saved in the folder which is given by the save image function. I'll go to that now. So the save image function does three functionalities. It saves the face image with the current timestamp at the bottom left corner of the image. It displays it as a pop-up in a new window. And last but not the least, it sends it to WhatsApp and email if their Boolean flags were enabled. Here we again do an additional check to see if the face is big enough. And then we crop the face from the frame with the 100 pixels at the top at each corner of the frame, so that we don't miss out on any essential details for the face. And in case after this cropping the face becomes null, we return because it's not possible to save the image. At this part of the function, we just put the timestamp at the bottom left corner of the image captured. And in this part, we basically save the image in the original and canny folders with the timestamp. So as you can see over here, the timestamp is in the format of year, month, date, hour, minute and seconds. So in this way the image is saved, the file name for the image. This part of the code deals with the WhatsApp and email functionality. We have used multi-threading in this because when we use single thread, so when the process is taking a good 3 to 4 seconds for the WhatsApp and email sending those messages, the program was getting stuck, the video feed was getting stuck. So to prevent that and promote concurrent execution, we have used the threading functions: thread send message, send image to WhatsApp, and thread send mail to the email ID of the person. Those modules are covered in these two scripts, which will be explained later. There's another function called canny edge detection, which was responsible for the black and white and the highlightation of the edges in the highlightation of the face edges in the frame. So it basically just reads the image from the image path that is provided, performs canny edge detection, and it saves it to the canny folder. And the last folder that the last function that we have to cover is the side-by-side pairwise display of the original and canny images. So this function basically takes the input parameters for the part to the original image folder and the canny edge folder, and then in the for loop it iterates through each image present in both of these folders, and it uses matplotlib.pyplot functions for effective plotting. It uses the subplot functionality, which basically means here 1, 2 being 1 row and 2 columns. Put the original image in the first column, 1, 2, 2. 2 meaning put the image in the second column, that is the second cell of that subplot. And with this we come to the end of the main overview of the demonstration. The further WhatsApp and mail functionalities will be explained by Karan now. Thank you.